All right, the section we're doing right now is 4.4, calculating the slope of a line. For instance, if we have this green line here, and we want to look at the graph and calculate the slope, we can do that by looking on the grid and finding 2 points where it intersects the grid lines. There's 1 point, and here would be another point. When calculating slope, you should think of it as a change in y over change in x. We can write this by setting it up with the capital delta symbol, which means a change in y and change in x. Well, let's calculate the slope here. We have our 2 points, a change in y. Since we are going to be working with the y-axis is the vertical axis, and the x-axis is the horizontal axis. So change in y, how far up or down does it go from one point to the next? Well, here would be 1, 2, 3. Since it goes up, that is a positive 3. We put that on top of our fraction. Change in x on the bottom of our fraction. What is the horizontal run? And here's 1, 2, 3, 4, 5 spaces. And since it went to the right, that would be a positive 5. So you have 3/5 as your slope for this line. This is not the only slope that we could have used. Let's look at this next example here. Same line. We're going to use 2 different points to calculate the slope. For instance, we can use this point down here. And we can use this point right here. We still calculate the change in y over the change in x. Let's say, for instance, we're going to be going from the point here on the right so the rise, remember, the y-axis is the vertical axis, so we're looking for the vertical change here, the change in y. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Since we went down, that was a negative 9. And the horizontal run here, one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And because we went left, that's a run of negative 15. The change in x would be negative 15. So we have the slope as negative 9 over negative 15, which we're not finished with yet. We have to simplify this, and we know that when we have a negative divided by negative, we get a positive number, and the number that goes into 9 that also goes into 15 is 3. So therefore 9 divided by 3 is going to leave us with 3, and 15 divided by 3 gives us a 5. And we have a slope here of positive 3/5. And if we look at the previous page that we just worked on, the slope for that one was also 3/5. Make sure you make it a point to always reduce your fractions as far as possible. Let's look at another example here. This line here, I have a purple line, dark purple line. If we look, we can find a point that crosses the grid. Right, there's a point. There's another point. There are numerous points along this line where it crosses. We can pick any two. It doesn't matter which two we pick, because as long as we reduce our fractions, we will get the same slope for every pair of points that we pick. So if we look, we will just go ahead and take these 2 points here. So our change in y over a change in x. So for this example, we've went down 1, 2, and 3. So when we go down, it's negative. So the change in y was negative 3. There's the y-axis. Now we're going to figure out the horizontal change, or the change in x. We're going to move to the right 1, 2 spaces. And we did move to the right here, so that's a positive 2. And we have negative 3 over 2. That's our slope. Looking at the next example here, we're going to figure out some points if the grid line crosses. Let's try again here. It crosses exactly there, and exactly here, and exactly here. And let's calculate the change in y over change in x. And Remember, we have a y-axis, which is the vertical. X-axis is the horizontal axis. So change in y over change in x. So we get from the far right point down, we're going to go down 1, 2, 3, 4, 5, 6, 7. The change in y is -7. And for a change in x, which is a horizontal change, we move like that. 1, 2, 3, 4, 5 spaces. And those are left, so we're going to say -5. Since it went left, it's a negative. And now we have -7 over -5. And when we reduce, a negative divided by a negative will give us a positive. And there's no number other than 1 that goes into 7 that also goes into 5. So we cannot reduce that fraction. We just leave it as 7 over 5. And therefore the slope is 7 over 5. We have another example here. Let's pick points on where it crosses exactly. Crosses here and here. Keeps crossing. I think that's going to be enough points to do our calculations. So we're going to say a change in y over a change in x. Y-axis is vertical, x-axis is horizontal. So a change in y is going to be a vertical change. So we have gone down 1. So going down 1, going down means we go negative, and we went down 1 space. And then to the right, 1 space. To the right is a positive. So the change in y is -1. The change in x is a +1. A negative divided by a positive will give us a negative, and 1 divided by 1 gives us 1. Our slope here is -1. You could have also picked 2 other points. Could have picked this point here along with the very first point, and let's do the change in y here. Change in y or the change in x. Change in y is a vertical change, so we're going to go up. We go up 1, 2, 3, 4, and when we go up, it's a positive number. So we'll say +4. And our change in x is a horizontal change. And here is 1, 2, 3, 4. This was a left horizontal change. So going left means we go negative, and we went 4 spaces. So we'll put the -4 down on the bottom of the fraction. We have a positive divided by a negative, which leaves us with a negative, and 4 divided by 4 is 1. And if we notice, they are the same slope. If you have the same line, they should have the same slope. Let's look at this one here. This one here is a little bit steeper than the other ones we've worked with. And if we look, crossing that point, and at that point, and that point, crosses again, and again, and again. There are numerous points it crosses at. We only need 2 of them. So a change in y divided by a change in x. Change in y is your vertical change. So for this one, we're going to go up. So we've gone up 1, 2, 3. If we go up, it's a positive number. So we've gone up positive 3. That's our change in y. And our change in x is a horizontal change. So we're going over to the point, and we've moved over 1 to the right. If we move to the right, it's a positive number. So we have 3 over 1 now. Anytime that we have 1 on the bottom of a fraction, it is equal to the number that is on top of the fraction. So the change in y divided by the change in x is going to give us 3. The slope of this problem is 3. We noticed that the slope here was 3, and it was a line that was a little bit steeper than, say, this line here that had a slope of -1, and it was a little bit steeper than the line here that has a slope of 7/5, which is approximately, actually it's equal to 1.4. The slope here is 1.4, and with a slope of 3, it was steeper, quite steeper than this line here that has a slope of 3/5. Let's go back to where we were. Here's our last example that we just worked on. These graphs that we've just worked on have all had slopes that involved numbers that were not 0. And if we look at this graph here, the orange graph, this one is going to end up with a slope of 0. If we go ahead and still calculate it, we can still calculate it as a change in y divided by a change in x. And we can pick any 2 points we can tell it crosses the grid at all of these points. So if we just want to do a change in y is going to be the vertical change, and from one point to the next, there is no vertical change. It doesn't rise any numbers, and it doesn't decline any numbers. So if we write that down, that's going to be a 0 change in y. And to get from the point on the far right to the next point over, that's going to be a change of -1, and that's our change in x. So we have 0 over -1, and anytime you have 0 on top of a fraction, the slope is 0. Horizontal lines will have a slope of 0. Now you might be wondering, what about a vertical line? What kind of slope does a vertical line have? Well, still follow the same steps that you've been doing. And if we look, once again, it has numerous points along the grid. But we're just going to work with those two. So to get from the top point to the next point down, that's your change in y. So it goes down 1, which that's a run. Or I'm sorry, not a run. That's a -1 change in y. And the change in x, how far left or right does it move? It doesn't move at all left or right. There is no change in x. So we're going to put 0 on the bottom. And using our number sense here, we know that you cannot have 0 on the bottom of a fraction. So therefore, we call this one, it has an undefined slope. It has an undefined slope. So vertical lines will have an undefined slope. Quick recap of a horizontal line. A horizontal line will have a slope of 0, while vertical lines have an undefined slope. Now, what if you're only given the ordered pairs? You might given the scenario that will say, find the slope of -3, 2, and 6, 4. Well, you could graph these 2 points on a coordinate plane and then use what we've been doing in the previous examples to calculate the slope, or you could use the slope formula. Slope formula, we will use the variable m for slope. So here's the formula. If you want to write that down, you may remember it from some previous math courses. So the slope m, on top we have y sub 2 minus y sub 1, and on the bottom we will have x sub 2 minus x sub 1. And this is still the same as what we've been doing graphically, as saying it's a change in y. You find the change from the first y value to the second y value over top of a change in x. You find a change from the first x value to the second x value. So if we look here, we can write below these, we know x is on the left and y is on the right for both of them. And we can look and say that this is the first point, and the one on the right, we can label it as the second point. And we just substitute those numbers into our formula. So y sub 2, if we look at the right point, is 4. Right above y sub 2 is 4. And we're going to get y sub 1 from the left point. And above y sub 1, we have 2. So on the top, 4 minus 2, which we know 4 minus 2 is 2. Now to find the change in x sub 2, which is from the right point, that's going to be a 6. And from the left point, x sub 1 is going to be negative 3. We know that when we have subtracting a negative, we change it to adding a positive, and therefore 6 plus 3 gives us 9. And the slope for this example is 2 over 9. We think about reducing it. There's no number that goes into 2 that also goes into 9 other than 1. And we don't want to reduce by 1 because it just gives us 2 over 9 again. There's one example for you there. Let's calculate the slope for another example. Let's use negative 2, 2, and 3, 4. Negative 2, 2, and 3, 4. Remember your slope formula. M is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. You might have the question, how do you know which one is y sub 2 and which one's y sub 1? If you're going to make the value here of negative 2 to be x sub 1, the y value of positive 2 also has to have the subscript of 1 with it. And if the 3 is x sub 2, the 4 has to have the subscript 2 with it. They have to, if they come from the same point, they have to have the same subscripts. We will do this example, and then we'll do the same problem a different way on the next page, just to show you that you can how you can set it up differently. So we still have y sub 2, which is 4 minus 2, and x sub 2 minus x sub 1, 3 minus negative 2. Four minus 2 will give us 2. And if we look, we know minus and negative will give us addition. Our slope is 2/5. Let's set it up differently here. I'm just going to erase the values underneath here. Let's set this up now and just show you that if this is x sub 1, this y value has to have a subscript of 1. And when I say that, I'm saying x sub 1. Sub means subscript. If I make this negative 2 to be x sub 2, the y value has to have a subscript of 2 with it. And let's look here. M is equal to, well, we're still going to use the same slope formula, but in this instance, y sub 2 is 2, so we have 2 minus, and y sub 1 is 4. 2 minus 4. And if we look, x sub 2 minus x sub 1, x sub 2 now is negative 2, minus x sub 1, which is 3. Comes from the point on the right. And do your calculations here. 2 minus 4 will give you negative 2. And negative 2 minus 3 gives you a negative 5. We know that negative divided by negative is going to give us a positive, and 2 and 5 cannot reduce, so our slope is 2/5. And if we look, they are the same slope. We just have to make sure that the numbers that you use in your formula have, when they come from the same point, they use the same subscript. And if you keep things aligned like that, you should be getting the correct slope for your calculations. An example here, let's find the slope between the point negative 1, 2 and 3, 2. If we look, let's say x sub 1, and this one is y sub 1, x sub 2, y sub 2. We're going to go ahead and plug these numbers into our formula. Y sub 2 from the right point is 2 minus y sub 1, which is from the left point, and it is also 2. On the bottom, x sub 2 from the right point is 3, and x sub 1 from the left point is going to be a negative 1. So our formula says x sub 2 minus x sub 1, so we have x sub 2 minus, and x sub 1 is negative 1. Minus negative means we're going to be adding. So 2 minus 2 will give us 0, and 3 plus 1 gives us 4. And we know that 0 divided by 4 will give us 0. Should trigger a thought in your head that back when we had a graph and we found a slope of 0, it was a horizontal line. So therefore, we have found from those 2 points that the slope between the slope of a line through those 2 points, the slope will be 0, and that this is a horizontal line also. What is the slope of a line that falls be? What is the slope of the line that is going through these 2 points, 0, 0, and 3, negative 3? Go ahead and label those. And we say m is equal to, and here's your formula, y sub 2 minus y sub 1 on top, which is the change in y, and then x sub 2 minus x sub 1 on bottom, which is the change in x. So we're going to say y sub 2 is negative 3 minus y sub 1, which is 0, x sub 2 from the point on the right is positive 3 minus x sub 1, which is 0 on from the left point. Do our calculations here. Negative 3 minus 0 will give us negative 3, and 3 minus 0 gives us a positive 3. A negative divided by a positive will give us a negative, and 3 divided by 3 gives us 1. So the slope between 0, 0 and 3, negative 3 is going to be negative 1. Let's look at this example here. We have 4, 1 and 4, negative 5. Go ahead and assign labels. And your formula. And so now let's plug in the numbers. Y sub 2 is negative 5 minus y sub 1, which is a positive 1. That's over top of x sub 2, which is 4, minus x sub 1, which is also 4. Do your calculations. Negative 5 minus 1 is negative 6, and 4 minus 4 is 0. And when we have 0 on the bottom of a fraction, you have to remember that this is an undefined slope. An undefined slope. Can you remember what type of line has an undefined slope? Maybe if I give you a graph here, that might help you out. A vertical line has an undefined slope. So when we calculate a slope like negative 6 over 0, and we know that it has an undefined slope, we can say that the line that goes between these 2 points, 4, 1 and 4, negative 5, will be a vertical line. Let me give you a few problems here. I'll give you 3 problems. You can try these, and on the next few pages, I will work these out for you. So as soon as these problems come up, it might be a good time for you to pause the video, and after you get these problems worked out, then you can play the video and see if the answers that you got on your paper are the same as the answers that I get. Let's see if you can calculate the slopes of those three of the lines that go through those pairs of points. There will be problem 1, there's problem 2, and problem 3. Alright, let's solve these problems out. First one had the points 1, 5 and 5, 2, and it wanted us to find the slope of the line that goes through those 2 points. So we want to say m is equal to y sub 2 is 2 minus 5. Y sub 2 minus y sub 1. X sub 2 minus x sub 1 is going to be 5 minus 1. So therefore, let's do our calculations. 2 minus 5 is negative 3, and 5 minus 1 is 4. Our slope, negative 3 over 4. The second one here, wanted you to calculate the slope of the line that went between 3, 1 and 5, 4. So therefore, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And this is 4 minus 1 is 3, 5 minus 3 is 2, and your slope is going to be 3 over 2, or you can also say 3 halves. We do not need to change this to it's an improper fraction now. We don't need to change it to a mixed number, because when we start graphing lines using slope, we need the 3, we need a change in y on top. We need that to be a number we can easily use. And then on bottom, the change in x. And the last problem that you worked on wanted you to calculate the slope of the line between 8, 6 and negative 2, negative 9. So m is equal to y sub 2 minus y sub 1 over top of x sub 2 minus x sub 1. Negative 9 minus 6 will give us negative 15. Negative 2 minus 8, negative 10. We know that a negative divided by a negative will give us a positive, and we also know that 5 goes into 15 and 10, so we're going to reduce this fraction by 5. So 15 divided by 5 is a 3, and 10 divided by 5 is 2. So our slope for the line that goes between those 2 points, 8, 6, and negative 2, 9, is 3 halves. Sometimes you're going to be giving a point and a slope, and the question will ask you to find the value of either x or y. So if we look at this problem, it'll say 2y is our first point. Our second point is going to be 4, 5, And the slope of the line that goes through those 2 points will be 2. So they want us to find the value of y. So we have a line that has a slope of 2, and we know it goes through the point 4, 5, and it will pass through an x coordinate of 2, but we need to find out what the y coordinate is going to be. Well, you know the slope formula. Here's the slope formula. Now we can substitute some values in. Okay. Well, we have x1, y1, x2, y2, and we know m. So right below m, we can put 2. And then we go ahead and plug in y sub 2 minus y sub 1, and y sub 1 is the value of y that we have to solve for. Then we have x sub 2 minus x sub 1, and this is what we have. So how do we solve this equation for y? Well, we know we can make 2 over 1, and we still have 5 minus y over 4 minus 2, and we can, instead of writing 4 minus 2, we know 4 minus 2 is 2. So this is where we move to. Here's our formula, and we've just substituted in, and now we're going to solve this problem. There's an equal sign between there, so we know that we can do what you commonly refer to as cross multiplication. So first off, 2 times 2 is equal to, and secondly, 1 times everything that's on top, that's 5 minus y. And this is an equation that you can solve for the value of y. 2 times 2 is 4. And we use the distributive property to distribute that 1. 1 times 5 is 5. And 1 times negative y is negative y. You have to try and get y by itself, so we have to solve for y. The opposite of a positive 5 is a negative 5. Subtract 5 from both sides. 4 minus 5 will give you negative 1. And we drop down the negative y. Don't forget to keep the negative sign with the y. How are we going to get y by itself here? Divide by negative 1, divide by negative 1. On the left side of the equation, we have negative 1 divided by negative 1, which gives us a positive 1. And on the right side, you have negative y divided by negative 1. And we know negative divided by negative is going to give us a positive. And y divided by 1 leaves us with y. So therefore, your answer, y, should equal 1. Let's try one more of those. This time we are going to, let's solve for the value of x in this equation. So find the value of x here. Let's say x2, and it's going to go through 4, 7. The slope will be let me change this here. The slope will be 5/2. So I want you to find the value of x when you have a line that goes through the point 4, 7, has a slope of 5/2, and find the value of x with the y coordinate of 2. So let's go ahead and label. That's not an x. So, using your formula here, y2 minus y1 over top of x2 minus x1. Here's your formula. So let's go ahead and plug in what we know. Well, we know m is 5/2. So we say 5/2 is equal to y2 minus y1, 7 minus 2 over x2 minus x1, 4 minus x. So when we do this, let's say it's 5 minus everything on the bottom. Everything on the bottom is going to be 4 minus x. And 7 minus 2, well, that's equal to 5. So 2 times 5 will give you 10. 2 times 5 will give you 10. So now you have to solve for x here. Use the distributive property. 5 times 4 is 20. 5 times, remember, that's a negative x. So 5 times negative x, so positive times a negative is a negative. And 5 times x is 5x. That's equal to 10. Trying to solve and get x by itself. In order to do this, you have to subtract 20 from the left side, subtract 20 from the right side. 20 minus 20 will cancel out and give you 0. You're left with negative 5x, and that's equal to 10 minus 20 is negative 10. To get x by itself, you divide each side by negative 5. Negative 5 divided by negative 5 will cancel out to give you 1. So you have 1x. And negative 10 divided by negative 5, a negative divided by negative will give you positive. And we know that 5 goes into 10 twice. So therefore, x is equal to 2. And you have calculated the value for x. Let me give you 2 of those problems to do. let's say 3y, and it's going to pass through -2, 1, and the slope is going to equal 3/5. That'll be the first example. Give me a moment here and I'll figure out a second example for you. In the second example, it's going to pass through -3, -5. It also passes through x 3, and it's going to have a slope of -2. You go ahead, and now might be a good time to pause the video so that way you can work on problems 1 and 2. And then on the next few pages I will work those out and you can see a worked out solution. Alright, let's go ahead and work those problems out. We have to find the value for y when we have a line that passes through a -2, 1 with a slope of 3/5, and the x-coordinate is going to be 3, so we have to find the value of y there. So setting this up, we have m is equal to, slope is 3/5, so we say m is equal to y sub 2 minus y sub 1, y sub 2 minus y sub 1, over top of x sub 2 minus x sub 1. -2 minus 3 is going to give us -5, so therefore 3 times -5, -15, and 5 times everything that's on top, 5 times 1 minus y in parentheses. So let's go ahead and do the distributive property. 5 times 1 is 5. 5 times -y is -5y. And we have -15 on the left side here still. Let's solve and get y by itself. So the opposite of a +5 is a -5. So that means we subtract 5 from both sides. -15 minus 5, -20. Those two 5's canceled out. The 5 and the -5 cancel out. And we're left with -5y on the right side. Try to get y by itself, so we say we're going to divide by -5 on the right side, so therefore we must divide by -5 on the left side. -5 divided by -5 leaves us with 1y, and -20 divided by -5, and negative divided by negative makes a positive. 20 divided by 5 is 4. The answer is +4. The next problem that you had, the line passed through 3, -5. You were trying to find the x-coordinate when the y-coordinate was 3. and we had a slope of -2. So in setting this up, you say m is equal to y sub 2 minus y sub 1 over top of x sub 2 minus x sub 1. We know that -2, we can put it over top of 1 for a cross multiplication. And we know that if we have minus and negative, 3 minus -5, it becomes 3 plus 5, which is 8. So we have 1 times 8, which will give us 8. And then we also have -2 times everything on bottom. -2 times the difference of x and 3. Solve this out. First step should be to distribute. -2 times x gives us -2x. -2 times -3 will give us a positive 6. And we still have 8 on the left side. Let's get x by itself, so subtract 6 from both sides. 2 is equal to -2x. 6 minus 6 will give us 0. Those canceled off. And then how do we get rid of -2 in front? The opposite of multiplying by -2 is dividing by -2. Divide by -2. -2 divided by -2 will leave us with 1. And then we have x. On the left side, we have a positive divided by a negative, so our answer is going to be negative. We have 2 divided by 2, which is 1. So in this one, x is equal to -1. I believe that wraps up our lesson on slope. There are a few different ways that you have learned to find slope today. And if you have any questions, see me in class. Thank you for watching.